Hello everyone, welcome to another useful session related to PostgreSQL. In this video, we will learn about an interesting topic related to PostgreSQL called temporary file generations. Sometimes a query that usually runs quickly might take a long time to complete, and suddenly that query became very slow. But when we troubleshoot at those slow queries, we usually look at indexes, query execution plans, or some of memory settings. But this happens when a PostgreSQL does not have enough memory to perform operations like sorting or hashing. So it usually uses some space in the disk and creates temporary files. Since accessing the data from the disk is much slower than accessing it from the memory, so the query takes usually longer time to complete. In this demo, we will see why these temporary files are getting created and how to identify those temporary files and what is the resolution to reduce creating those temporary files, and how we can improve the query performance and all. So for that, let me create first a sample database. I have created a sample database, and now let me connect to this database. I have connected to that database, and let's create a table under this database. Table got created, and now I am going to populate some data into the table. It usually takes some time. So as I am inserting 10 million rows in this table to simulate a large production table, so it usually takes a little more time. Yeah, it was done, and we successfully inserted 10 million rows into this table. And let me verify whether all the rows are created or not. Yeah, all the rows were inserted successfully, and let me first check the size of this table. So it will be helpful to understand how much data the PostgreSQL will process. So the size of this table is around 965 MB. Then we have to run analyze, so that why we need to run analyze means it will update the latest table statistics so that PostgreSQL query planner can generate an efficient execution plan for this. Let me run the analyze for this table. So our table statistics are updated, and now I am intentionally setting workmem to very low so that the large operations may not fit into this RAM, so it will definitely spill into the disk. So if they don't have enough memory for the sorting operation or hashing operations, so the PostgreSQL will obviously uses the space on the disk. So and like that the temporary files will getting generated. So to simulate that, I intentionally set the workmem to 5 MB. So it was set to 5 MB. And in order to capture the temp files generated, we need to set the log temp files to 0. By default, PostgreSQL does not log temporary files. Setting this to 0 will log every temp files that getting created. So I am setting the log files to 0. So it was set to 0, and let me verify. So it was set to 0, and in order to find out the temp files got generated in the log, first we need to check log directory. So it is under varlib PostgreSQL 18 main. I am checking this because it stores the log files so that we can monitor temp file generation, and we can monitor this temp file generation once after running this sort query. So it was executed, and we can notice that it uses an external med sort. External means the sort could not fit into the memory. So PostgreSQL created temporary files on the disk. So now we have to check the temp files are generated in this log directory or not. I will open another session and I will show it to you. we have to look into the latest log files. So now you can able to see these temporary files are generated in this base directory, and the path is base/PostgreSQL_temp, and the size is around, the temp file size is around 14 MB. And we can also see this temp file generation using a system view. So I will show that one also. So this is the system view, and it will also gives us how many temp files are getting generated, and it also gives us number and size of the temp files, and it will also show us database statistics also. Here we can able to see that the temp files created are 3. And now what I am going to do is I want to increase this work mem to 64 MB, and so that that sort operation will entirely takes place in the RAM itself. So let's see whether that when we increase the work mem to 64 MB, will the operation took place in the RAM, or it will spill into the disk. I am setting the work mem to 64 MB. Now it is set to 64 MB. And now I am rerunning this query to see whether the external merge happened or it is entirely processed in the memory. I will off this one and I will show it. So here you can observe, and this time it will not spill into the disk, and this sort operation was entirely happened in the memory, and you can see this and it uses quick sort algorithm, and it executed entirely in the memory. And from this demo we can understand that if the work mem is too small, PostgreSQL spill the data to the temporary files on the disk, and it causes increase of disk IO operation, and that will leads to slowing down the query execution. After increasing the work mem, the sort completed entirely in the memory using the quick sort algorithm, eliminating the temporary file generation, and it significantly improves the performance. But we should be very conscious while we are increasing the work mem, and when we are not tuned it properly, and it will sometimes it will cause memory pressure, and that will also affect the server. And so that we have to be very careful while we are tuning this work mem, and because this work mem is allocated per query operation, and that will obviously increases the memory that will obviously causes the pressure in the memory. And that is all about how the temporary files are getting created, and what is the effect of these temporary files, and how it slow down the query performance, and how we can resolve the this temporary file generation issue. And that is all about this video.